The ME3851A and 3951A are easy to operate low-frequency broadband EMF meters that measure AC electric and AC magnetic fields. They can also be referred to as AC electric field meters, Tesla meters, or Gauss meters. The meters are designed to measure the invisible pollutants that radiate from electrical wiring and devices that use AC power. The ME3851A measures frequencies between 5 Hz and 100 kHz, or 100,000 Hz, and the ME3951A has a wider frequency range covering 5 Hz to 400 kHz, or 400,000 Hz. Both meters cover these frequencies in 4 ranges. The first frequency range covers the entire band of the meter, which is useful for detecting all sources of EMF. In this range, the meter must be very stable. It is recommended to use a tripod when measuring in this range. The second frequency range allows the meter to detect only frequencies of 16 Hz. In Europe, this frequency, which is actually 16.7 Hz, is used for the AC power supply to many electric trains. This frequency is not used in North America. The third frequency range is the default range, which is useful for measuring in areas where you want to exclude frequencies below 50 Hz. And finally, the fourth frequency range will only measure EMF sources above 2 kHz. These higher frequency electric fields are commonly referred to as dirty electricity. Included in the K5 carrying case is the meter with a rechargeable battery installed, AC adapter charger, operating manual, grounding cable, grounding clamp, warranty, and certificate of factory calibration. Both the ME3851A and 3951A offer excellent sensitivity down to 0.1 volts per meter for AC electric fields or 0.1 nanotesla, which is 0.001 milligauss for AC magnetic fields. The maximum field strength they can measure is 1,999 volts per meter and 1,999 nanotesla, or 19.99 milligauss. Both meters include an auto power off function after 40 minutes to conserve battery life, and a Geiger counter audible signal that is proportional to the measured field strength to assist with source detection. The battery status can be displayed by pushing this button as shown. The display will show a 1999 if the battery charge is OK. When a low battery message appears in the display, recharge the meter by plugging in the included AC adapter to the power jack as shown. This green light will show that the meter is charging. A full charge will take about 11 hours, and the green light will then go out when the charge is complete. Both meters have AC and DC outputs that can be used to supply signals to more advanced testing or data logging equipment. To disable the auto power off feature for data logging, simply connect the AC adapter, then power the meter off, then on again. Both the ME3851A and 3951A have a test switch to confirm calibration offset. In test mode, the meter should show values close to 0 in all frequency ranges. If this value is above 0, the displayed value would indicate this increased tolerance. The ME3851A and 3951A are single-axis meters, which are useful for identifying sources of low-frequency EMF. To measure AC magnetic fields, set the field type switch to M, set the frequency range to 50 Hz to 100 kHz or 400 kHz, set the range to 199.9 nanotesla, and power the unit on with the sound option. Note the indicator on the display next to the M showing that you are in magnetic mode. Slowly scan an area and follow the direction of the highest field strength. The Geiger counter tone will also increase closer to the source. If the meter shows only a 1 at any point, then switch the range to 1,999 nanotesla. After locating the area of concern, rotate the meter in all directions and note the highest reading on the meter, shown in nanotesla. If the measured value is above 1,999 nanotesla, the display will look like this, again showing only a 1 on the far left of the display. To measure AC electric fields, set the field type switch to E, set the frequency range to 50 Hz to 100 kHz or 400 kHz, set the range to 199.9 volts per meter, and power the unit on with the sound option. Note the indicator on the display next to the E showing that you are in electric mode. Slowly scan an area and follow the direction of the highest field strength. The Geiger counter tone will also increase closer to the source. If the meter shows a 1 at any point, then switch the range to 1,999 volts per meter. After locating the area of concern, rotate the meter in all directions and note the highest reading on the meter, shown in volts per meter. If the measured value is above 1,999 volts per meter, the display will look like this, again showing only a 1 on the far left of the display. If you wish to measure only what's referred to as dirty electricity, switch the meter to its 4th bandwidth range for 2 kHz and above. Common sources of dirty electricity are compact fluorescent light bulbs, dimmer switches, and switching power supplies. Here, we see the meter reading these higher frequency magnetic fields coming from a compact fluorescent light bulb. Electric fields can be measured reference to ground or ungrounded, potential-free. For best results, ground the meter by connecting the included 17-foot cable to a copper water pipe or to an electrical outlet using a grounding plug. For more advanced information on grounding procedure and advanced measuring tips for electric fields, please watch our advanced electric field measurement video. Once you have determined the highest readings, compare them to the latest building biology guidelines. Currently, SBM 2008 is the most recent building biology standard. A reasonable goal after mitigation would be to have the levels reduced to the slight concern level, as shown below. Note that nanotesla can easily be translated to milligauss by dividing by 100, so 100 nanotesla would equal 1 milligauss. For more detailed information about the ME3851A and 3951A, please visit the Safe Living Technologies website at slt.co.